Hello and welcome to my first video on YouTube. This is Astro Guy here. Today we're gonna talk about something that I never found anyone on YouTube discussing before. It's related to the manufacturing industry, okay? So sometimes if you are working in the manufacturing industry and you would like to make some sort of a reverse engineering process, let's say you receive a task like this. So if the customer gave you a drawing like this and you were asked to transform it into a 3D CAD model in order to manufacture it later on, how can you handle a task like this? The prerequisite for this process is that you have already mastered a CAD software. In our case, we are using Solidworks software. It is one of the most used worldwide in many companies and by many users, many professionals, and so on. The second, you already know the basic rules of drawings, specifically mechanical engineering drawings. I mean, you know how to read views, you know the basic views, and the section views, the dimensioning, tolerancing. About GD&T, we're not gonna use it for now, okay? So, how can we work on a project like this? Stay tight and follow with me. We're gonna make in this tutorial, we're gonna make the drawing of this. We would like to make a 3D model by reading all of these views we have. Let's assume this is called the elevation. This is the plan. We have two section views with two detailed views. So let's get started, okay? Now we are heading to our SolidWorks software, which is the CAD software we are using in this video. We make a new part. Waiting for it to open. As I said previously, I have assumed that you already know a CAD software like SolidWorks, sketching features and all this. So it's a little bit advanced topic. If you are a professional CAD user, then this video will be for you. If you are not, maybe upon your request, we can make some tutorials for beginners or even absolute beginners. So leave a comment below if you have any suggestions for the upcoming videos. First, we're gonna start with a sketch. We select our plane. I would prefer in that case we draw on the right plane. Let's make a center line with a relation related to the origin. We make the midpoint of our center line is coincident with our origin. I make this because I highly recommend we make the drawing as symmetric as possible and fully defined. It makes the work much easier. Let's say we're gonna make 3 lines like this, perpendicular to each other. Okay. Now we are heading to our drawing in order to read the views, to make the 3D model of this. If you look at this view, which we called it already the division, we have the outer radius of 1060, which indicates that this model is a revolved model. We have like R, which means this is a circle or something. So, and he gave us a section view here, AA. If we checked it, AA, we can make like half of this drawing and we'll just simply revolve it. You can see we have 132 by 53. We could just add this 132 and we set 53, and of course this line with this line are equal. I will show you something now. We make a center line like this, we make it coincident with this line, and we make the midpoint with with this point of the center line coincident to make it more symmetric. He gave us 1060 of radius, so as we're gonna revolve it around this center line, we add the dimension here, 1060. Okay, great. Now we would like to continue. Let's check our drawing. Oh, you might think that there are some details missing from this view, so I highly recommend we start looking at some other views. As you can see, he gave us like a detailed view here, which could be beneficial to make our drawing fully defined. But before that, he gave us like an angle here, a center line between this line, and those two lines are symmetric around this center line. Let's just make our initial drawing like this. We have a line and like this. We make the same from the other side. Here we go. This line and this line are symmetric about this center line. Okay, with 1 degree angle. You see, here we are. Now it's time to check a necessary dimension we could use from this detailed view, DD. You see he gave us 2 points with 70 millimeter distance between them, around, or I say between the center line. That would be useful, and you can see here those 2 points could be on the same circle with the radius of 215. So we could use like a circle here, 215 radius. That would be 215 by 2, a diameter of 430. We just need this for construction. Okay, now we make a coincidence relationship like this. Here we are, and the distance between those 2 points would be the 7th we have just read. Oh, here we are. Now we would like to revolve this part of our sketch. Okay, so I highly recommend we close our sketch. As an initial drawing, we're gonna resume by following the other drawing parts like this. Okay, now we're gonna close it. Okay, now we're gonna revolve this in order to get our initial model. Okay, we head to the features, we use the revolve boss base. Now determine our axis of revolution, which will be this. Here we go. Okay, our initial drawing. Let's head back to our PDF file. So we have made this part of our drawing. Let's make the big circle. Hmm. We don't have a detail for this, so we are heading to our detail view once again. He gave us the outer diameter 430, which is the radius 215. That would be it. We can, from the right plane once again, from our origin point, 430. And if you checked this view, the ending of this circle or cylinder, as I should say, covers the whole initial model we have already created. Okay, so we extrude it in both sides up to surface. Let's select this, and from the direction 2 we make the same from the other side. Sorry, up to surface. Here we are, like this. Great. Okay, I think you have already seen some fillets like radiuses here, but don't worry, we will make the fillets in the final stage of our drawing. Okay, so don't have any concerns right now. Just forget about it. Now we would like to resume. So see, we have like some sort of a frame here. It looks like a rectangle from here, but it's not. We need more details for it. He gave us like the height of it, 187 minus 37 from one side, and definitely it's the same from the lower one. If we check this detailed view now, we have something to draw. You see, he gave us the detail for that thing, whatever you call it. You can let's see how can we handle a case like this. And if we checked here, he gave us like a distance like 9 by 190, which means that between this between the center line of this circle and this circle, 190 is the same here, the same here, the same here. So, and we see it must be symmetric, and he gave us like a distance here 205. So a drawing like this we're gonna draw from the top plane. Okay, uh, let's make a center line here and here. We make like this, 190 divided by 2. Okay, 190. So this is the position like of this. If we just make a count, yeah, it's this one we are talking about, or we're gonna make. Okay, so let's head to our detailed view. In order to draw this, he gave us like some details, but we need to know the distance. Did he give it to us? Oh yeah, he gave it to us. Look. From this center line to this center line will be 380 divided by 2. So make like we delete. Could delete this for now. Do we delete this? Oh, 380 by 2. Here we are. And we make like this a vertical center line. We're gonna use a dimension of 190 divided by 2. We make a circle of 39. Ignore the tolerance for now, we're not gonna be using it, okay? We don't need it for this video. So we're gonna make a center line here again. And we're gonna make the outer frame of this drawing a radius of 42, like this, this, radius of 42. We add a symmetric relationship like this, okay? We make, let's say this, we make a horizontal relationship. Here we go. Let's head back to our drawing. Use the center of this arc will be the same center as the circle. Make it coincident. Here we go. Let's delete our circle for now. We're gonna make it in a separate feature later, okay? Now we make like a line here, which is the distance of 12. This one is equal to this one. Okay, great. Let's check once again. We have an arc of 34. So if we subtracted 42 from 34, we get 8. So we can use the offset entities of 8. And we remove the select chain and we apply. We now can add a vertical line like this and another one like this. Here we are. We could use our trim entity, trim to closest. Like this, we remove what we don't want. Like this. Now it's a closed profile. The profile is completely closed, so we could add our like extruded feature. Let's check our distance from the upper detailed view. Now we have 187. From one side and from the other side will be the same. Here we are. Make it blind 187. Direction 287. Here we go. Now one is done. We will make some sort of a linear repetition, or I mean linear pattern, I'm sorry. 187. Okay. Now how many elements of these do we have? We can check that from this view. He gave us like we have drawn this one. We have from this side 1, 2, 3, 4. Let's add those 4. Okay. Linear pattern. Select this direction. Cannot be selected. Let's select this line. Okay. Spacing and instances, we make it 190 of 4. Now select our feature. Make it like this. Reverse direction. Let's check once again. Oh, we add one another. Okay. Can we add from... Okay. You see we have this initial 5, we need 5 from the other side too. So make a linear pattern once again from, let's select this direction, 5, reverse, now feature this one. Make it 6, like this. Okay, let's count, 1, 2, 3. Now we have 10 elements of this. We're gonna mirror it around the front plane. That's why I recommended to make the drawing as symmetric as possible from the beginning, okay? We mirror, select our features we would like to mirror around the front plane. We have this, this, and this. Okay. Now this is done. But if we check the drawing, you can see that it's not finished yet. I mean, you see this, we'll have to add of 37. Like we're gonna add a boss feature here. So head back, scroll back here. Okay, from the top lane, let's make a convert entities of here, here, and here. Now we're gonna close this profile and we're gonna extrude it. Let's select offset from surface from this and we make it, we leave 37. We will do the same from the second direction, direction 2, surface 37. Here we are. Now you see. And we have, don't forget about the through hole, okay, of diameter of 39. Make it here. It is the same center as the outer arc. 39. We make pass extrude, I mean cut extrude through all. Here we are. Anything missing? Let's check out from the upper detail view. We only have a radius of 20. We could add a fillet to this. 20 items to fillet. Let's select this edge and the one from the other side, this. Okay, now in our pattern we're gonna select these features too, to include all this, this, and this. Okay, perfect. We'll do the same here. We add this, this, and this. Great. We mirror. Something went wrong, wait. Select all this. Okay, it's fixed. Okay, great. We need to select the whole features. Now this part of our drawing is done. Let's head back to our PDF. Okay, so we have now we're finished with this element, with this and this. We're gonna make this through hole with diameter. We check our detailed view once again. You see we have 156 and 160, radius of 156 and radius of 160. How can we know, how can we read something like this? You see he gave us a section view DD, I mean detailed view from this section, and we don't really know what is the difference between 160 and 156. So it seems it's not enough. We need another detail from a second view or something. So let's check this one. You see this? Can you see this like a step or something? So this is a bigger diameter 160 and this is 156. I will show you how to handle this now. Let's make a drawing in our right plane. We make a circle. We start with the small diameter, which is 156. Okay. Extrude cut. We simply press on through all bows to make it. But we have done a mistake right now, so you must be so cautious. We made 156 as a diameter and it was a radius in our drawing, so don't forget to multiply it by 2. So you need a full concentration while working on this project, you see, a radius. Okay, and how are we gonna make 160? He gave us like it's from this, it's gonna be from the middle. We reuse the right plane and make a circle of a diameter 160. Don't forget to multiply by 2. Now we need to know the distance. I mean, if you can see, he gave us 360 distance from the outer, I mean from the final part of our initial drawing. You can see this is called CC. We could just check it from the upper view. CC is just on the middle. So if we added like a section view, we select our top plane in order to measure. Let's see. So this distance we can measure here from this edge to our right plane. It's 160 of distance. Okay, so we can, from our calculation, we could make our cut extrude. We make blind 160 minus 360. Once again, 1060 I mean, minus 360. This is the right value, excuse me, it will be 700. We add the same value in the second direction, like this. Top plane, section view. Let's look at it to verify our solution. You see, this is correct. Now let's head to our drawing once again. Now, did we finish our drawing? Actually not. We still have final thing to do. We have like some sort of a slot in our, you see this, like a slot. This is used for you know, the key of shafts. The key is one of the machine elements. You can read about it in any reference in the design of machine elements. So this slot's gonna be like a housing for a key used for shafts, okay? He gave a distance of 1060 and a width of 32. We could just make it could draw it on the right plane once again. We make a rectangle like this. Now it's here 32. Let's make this point with this point. We add a vertical relationship. In order to know the distance, we head back to our detailed view. He gave us a distance of 182 far away from the center line of the horizontal center line of the circle. That is coincident with the center point of the circle. In our case, the origin will be enough to add this relationship or add this dimension. We said 182, okay, like this. Now we could just make this line coincident with the origin. It's not going to be a problem. Just to make the sketch fully defined. Extruded cut. We make like mid plane of 160. Was it 160? Was it 160? Yes, it was. Okay. Now we press enter or just the green mark here. There we have it. We could mirror it as it is a symmetric part. Select our mirror. Feature. The cut extrude. Here we are. There you have it. Section view. It will be just like this. Okay, great. Now let's make sure our drawing is finished. We add the fillets. We have from the inside we have radius of 20, and from the outer ones we have radius of 10. Do we have any other fillets? Let's see. Yes, we do have here a radius of 50 and a radius of 50. Don't worry, we're gonna handle it. It's gonna be so easy. First we add the small ones. Let's start with radius 10. Here we are, fillet, radius of 10. Set the outer ones. This one, this one, this one, and this one. Do we have any more? Yeah, we have this one and this one. Add this guy and his friend here. Okay, we have added the 10 fillet. We now add the 21. It's just from the inside here, and make it from the other side, the lower part too, here and here. Okay, great. We have seen a fillet of 50. It will be here and here, the lower part too, and here. Great. Now our model is maybe it's completely finished. We're gonna check our views now, so don't worry about it. We're gonna verify our solution. This job is You need to be so accurate, precise, to avoid any mistakes while manufacturing your model. But as you can see, this damper, you could ask your client about the functionality of your products. It's divided into two parts, upper one and lower one. So we could just split this out like this. We make a line from here to here and we split this part. Could go to direct editing, split, cut parts. We have this one and this one. Okay. Hide your line, we no longer need it. Okay. Now this part is divided into two parts, upper one and lower one. You know, when you make a design as a professional designer, engineer, or a hobbyist or anything, this type of drawing you will have to consider the functionality of your product to make sure it's working properly. If we made like remove it just to make sure. It's supposed to be something like this, okay? So that's it. The drawing is done and ready for the next stage depending on the client's request. But now let's scroll back. We need to verify our solution. We check each view. So just make it by your eye. We're not gonna make it, we're gonna make it by our eyes. I mean, I hope the dimension is right. Let's check every view. Here we have like a I mean, forget about, I mean, let's check this view first. This view is simply gonna be the front view, okay? Like this. Here we are. You could just make it like this. Here we are. It looks the same, isn't it? So this view will be this. Now let's take our AA section. Okay, AA section will be a section from the middle in the specifically in the right lane. Okay, like this. Okay, I would prefer to reverse the direction like this. Here we are. Now you can see this is section AA. Okay, it looks the same. Just to verify your solution, he gave us also section BB. Let's say we're gonna make like a plane. Oh, okay. Let's make reference plane. That's okay here, and here. We make a mid plane between those two faces. Okay. So this we take a section about it from this side. See, we hide the plane for now. Can you see? It is the same, but in this drawing he added like a bolt or I mean a stud with a couple of nuts. It depends on the fixation he gave for just to fix it. I mean, I don't know specifically if this is stud or bolt or what, but it's like a stud with two nuts. Anyway, but we didn't add it to our drawing. We are making the big part only. Okay, so this view is correct. The detailed views are not a problem. It will be just the same. We could just check this view finally. Could exit our section views and hide one of our elements. We check this. Okay. It looks the same. Fine. So that's it. You have made your drawing. This is how to convert a drawing into a 3D CAD model. and you will like encounter a situation like this in many times. Many clients will send you drawing like this, and you will be asked to convert it into a 3D model. So the views gave us this model. Okay, great. Thank you so much for watching, and please give me your feedback. This is my first tutorial. If you want any more videos about these topics, don't hesitate giving a comment and giving me your feedback. Tell me how to develop my channel. And if you have any more, so if you have any suggestions, just give me your feedback and give me a comment. Give me, you know, goodbye.